So statements like x greater than 3 plus 5x or 5 plus 9x is greater than equal to 2. These statements are what we call as linear inequalities. And in a general form, we can write them as ax plus b is less than 0, ax plus b is less than equal to 0, ax plus b is less than 0, ax plus b is less than equal to 0. So these are some of the basic forms in which linear inequalities exist, and we'll be using those in our problem solving. Let's move on to some of the keywords that we use. So first one is the replacement set. So this is the set basically from where the values or the variable where the values of the variables are chosen from. So say our equation says that x belongs to or the answer belongs to natural numbers, then our replacement set would be anything from 1, 2, 3, 4, and so on. Similarly, we can have x belongs to integers. So it can be anything from can be anything from -2, -1, 0, 1, 2, and so on. So that's how the replacement set works, and we take the value from only these sets. Next, we have the solution set. So basically, a solution set is something which, when we replace the variable from, whose value if we replace the variable from, makes the inequality true. So basically, say we have an inequality x is less than 4, and our replacement set is x belongs to natural number. So in such a case, our replacement set would be 1, 2, 3, 4, 5, and so on, whereas our solution set would be x belonging to n, but the solutions would only be 1, 2, and 3. So that's how our replacement and solution sets work. Now let's look at how to represent these inequalities on a number line. So say we have an example of x is less than 5, and x belongs to natural number. So our solution set would be 1, 2, 3, and 4. So how do we create this? Let me just bring up a very quick number line. Let's start. So we have -1, 0, 1, 3, 4, and so on. So because our solution is something on the lines of 1, 2, 3, and 4, our answers would be highlighted as this: 1, 2, 3, and 4. So that's how we represent x less than 5 in terms of this number line. So let's try an example. So we have a solution set of x less than equal to 3. And now we have to represent it on a number line. But there's a catch. So we have 3 scenarios where we need to represent this. So first, when the replacement is natural numbers. Second, when the replacement set is whole numbers. And third, when the replacement set is integers. So let's get started. So first, for a natural set, solution set would be 1 and 2 and 3. Let's draw this. So because our solution set only consists of 1, 2, and 3, these would be highlighted, and that's how we show this solution set. Next, let's try whole numbers. So our solution set would be 0, 1, 2, and 3. So here, as a solution set is 0, 1, 2, and 3, we make this highlighted, and that's how we represent it with a replacement of x belonging to whole number. Let's do the integer one finally. So our solution set would be anything coming from the negative values to 0, 1, 2, 3. So so here we have x belonging to integers. Plus 1, 0, 1, 3 arrows showing that everything is coming from so on. And because everything is included in the negative space, and then 0, 1, 2, 3, we'll highlight all these points. So this is how we represent the solution set when our replacement set is an integer set. So let's try other questions. So now we'll solve some inequalities. So this one has some pointers. So we can add and subtract on both sides, then multiply on both sides with positive number. Then we have multiply or divide on both sides with negative number. Then we change the symbol of inequality. So the third point is the important one, and we'll follow these. So let's get started. Let's solve the following inequality. We have 2x minus 1 by 3 that is less than or equal to 4. Let's try this. So first we will multiply both sides by 3. We have 3 2x minus 1 divided by 3. See, as this is a positive number, the inequality does not reverse. So we get 2x minus 1 is less than or equal to 12. Now let's add 1 on both sides. Also see, if we add or subtract any number on both sides, the inequality remains the same. So we get 2x is less than or equal to 13. Now we again divide 2x by 2 on both sides. As it's a positive division, the inequality remains the same, does not reverse. So we get x is less than or equal to 13 by 2 or 6.5. And as our replacement set is x belongs to whole numbers, we will have x can be 0, 1, 2, 3, 4, 5, and 6. That's how we solve it. Let's try another question. So we have a given replacement set of this, and we have to solve the following inequality and represent the solution graphically. So our inequality is, so let's first divide the entire inequality. So let's first open the brackets on each side. 3x minus 3 is less than 2x plus 4 minus 9. Let's simplify on both sides. So we get 2x minus 5. So let's move these, so let's add 2x on each side. So we have, so let's subtract 2x on each side. So 3x minus 3 minus 2x is less than 2x minus 5 minus 2x. So this cancels out, and we are left with x minus 3 is greater than minus 5. Let's add 3 on both sides. We get x is less than minus 2. So this is our solution, and our solution set would be, looking at the replacement set, anything which is less than minus 2. So we'll have minus 5, minus 4, minus 3. And that's all. And we can represent it graphically as we have already done in the previous question. Similarly, let's solve another question where we have, so here we have two inequalities and our replacement set is whole numbers. So let's start. Let me first open the brackets. So we have 1 is less than or equal to 3x minus 6 plus 2 less than 10. Yeah, again, we can solve it to get 3x minus 2 less than 10. Now we'll add 2 on every side. So 1 plus 2 less than or equal to 3x minus 2 plus 2 less than 10 minus 2 plus 2, sorry. So we'll have 3 less than or equal to 3x, 2 gets cancelled, less than 12. Now let's divide by 3 on every side. 3 divided by 3, 3x divided by 3, and 12 divided by 3. This gives us 1 less than or equal to x less than 4. So this is our solution. And as our replacement set belongs to whole numbers, our solution set would be 1, 2, and 3. And that's how we solve this. I hope you like our video on inequalities, linear inequalities, and linear equations in one variable. If you like more content like this, please subscribe to our channel and don't forget to find digital product below where I have all the notes for each and every chapter that I go through. Thank you. See you soon.